Welcome to the DIY Honda Garage channel. DTC P0122 refers to an issue with a throttle position TP sensor A circuit, specifically indicating a low voltage problem. The throttle position sensor is critical for measuring the position of the throttle plate, which regulates the engine's air intake. This information is vital for the powertrain control module, PCM, to adjust fuel injection and ignition settings efficiently. When the output voltage from TP sensor A falls below a certain threshold, typically lower than 0.3 volts, the PCM detects this as an abnormal condition and triggers the diagnostic trouble code P0122. Understanding the importance and correct functioning of the TP sensor is crucial for overall engine performance, as it directly impacts the vehicle's acceleration and emissions. Located on the throttle body and integrated within its structure, any malfunction here can lead to significant driving issues if not rectified promptly. The throttle position sensor A, which is integrated into the throttle body, plays a pivotal role in measuring the position of the throttle plate. This sensor sends a voltage signal to the powertrain control module, PCM, which is responsible for regulating various engine functions, such as air-fuel mixture and timing. The expected voltage range for the TP sensor is approximately 0.3 to 5.0 volts, and a lower voltage indicates a failure in the reading. The throttle body, where the sensor is located, is positioned between the air intake and the intake manifold. A malfunction in this sensor can affect not just engine performance, but can also lead to safety issues while driving due to poor throttle response. Thus, diagnosing and resolving issues related to this sensor is essential for maintaining optimal vehicle function. Several factors can lead to the DTC P0122 error code. A low output voltage from TP sensor A, which measures the throttle position, can trigger this code. This low voltage can be caused by electrical circuit issues, such as short circuits or broken wires. Additionally, the function of the PCM is integral to processing the signal from the TP sensor. Hence, a malfunctioning PCM itself can result in this diagnostic error. Another potential cause may involve the throttle body where the TP sensor resides. If the throttle plate is not operating correctly due to mechanical failure, it could affect sensor readings. Identifying these issues is crucial to restoring correct functionality to the throttle system and ensuring safe vehicle operation. Symptoms associated with DTC P0122 can significantly affect driving performance and vehicle safety. Poor engine performance is usually experienced as the throttle may not respond correctly to driver inputs, leading to erratic acceleration or sluggish response. Drivers may also notice an increase in emissions due to improper air-fuel mixture ratios caused by the sensor's faulty readings. Additionally, the check engine light will illuminate to alert the driver about the underlying issue. It is essential to address these symptoms promptly, as they can complicate driving conditions, potentially leading to accidents or engine damage if not acted upon quickly. The first troubleshooting step in addressing DTC P0122 is to turn the ignition to the on position while ensuring the engine is not running. Utilizing a Honda Diagnostic System HDS or similar diagnostic tool, check the voltage reading of TP sensor A. If the reading is less than 0.3 volts, this indicates that the sensor is malfunctioning. At this point, the failure can be confirmed, suggesting either a problem with the throttle body itself or an issue within the electrical circuits supplying power to the sensor. Hence, proper equipment usage is crucial in diagnosing these electrical issues to ascertain where the problem lies. The second troubleshooting step involves inspecting the throttle body connector, which is a 6-pin connector, vital for the sensor's operation. First, ensure that the throttle body connector is disconnected to perform the test accurately. After disconnecting, switch the ignition to the IG mode and measure the output voltage at the throttle body terminals. A normal voltage reading should be around 5.0 volts. If the output is within the expected range, the throttle body may be at fault. Conversely, if the reading is low or absent, it signifies problems with the electrical circuits or connections, necessitating further investigation into wiring and connections. In the next step, focus on inspecting the VCC3 and THL1 circuits that connect to the TP sensor. This step is critical in ensuring that the power supply circuit vouches for correct voltage levels feeding the sensor. First, confirm that the circuit is not open, with a resistance measurement of less than 1 ohm indicating a good connection. Similarly, test the THL1 circuit to ensure it is not shorted to the ground. A reading of more than 1 megaohm is acceptable and indicates integrity. These tests help eliminate pressure points in the sensor circuit, isolating the problem further to help ensure any repairs made will address the root of the issue. Lastly, inspect the powertrain control module (PCM) connections to determine its functionality. The PCM acts as the control hub for various engine functions, relying on accurate data from components like the TP sensor. Conduct diagnostic tests to confirm that the PCM is processing signals accurately. If the prior tests indicate that both the throttle body and circuits are functioning correctly, the PCM emerges as the potential culprit. Any faults detected within the PCM will require either reprogramming or replacement. Verifying its integrity ensures that the fault does not recur, thus maintaining vehicle performance and safety. After performing the necessary repairs, it is crucial to recheck the voltage of the TP sensor. Ensure that the output voltage indicates normal functionality within the expected range to confirm that the repairs effectively address the issue. Following this step, it is imperative to clear the DTC from the vehicle's memory using the HDS tool and subsequently perform a test drive under varied driving conditions. This practice allows for observing the throttle's response in real time and ensures that no further issues stem from the TP sensor or related components. Comprehensive confirmation through these steps guarantees that the vehicle operates as intended. To prevent future occurrences of DTC P0122, regular preventive maintenance is necessary. Routine electrical inspections of circuits related to the throttle position sensor will help identify any developing issues before they escalate into significant problems. Monitoring throttle response during driving can also serve as an indicator of the health of the TP sensor and throttle body. Additionally, maintaining a clean throttle body prevents carbon buildup, which could impede the throttle plate's movement and impact sensor readings. Implementing these preventive measures is not only better for vehicle reliability, but also enhances performance and efficiency. In conclusion, recognizing the role of the throttle position sensor A is essential as it directly influences vehicle performance by regulating the air-fuel mixture for optimal combustion. Identifying the causes of DTC P0122, including low-voltage readings, circuit issues, or faulty components like the PCM or throttle body, is crucial for effective troubleshooting. The symptoms associated with this diagnostic trouble code, such as poor engine performance and illuminated warning lights, provide vital clues for rectifying the issue. Following the structured troubleshooting steps outlined not only assists in diagnosing the problem efficiently, but also helps in determining the root cause and ensuring thorough repairs. Keeping up with preventive maintenance enables drivers to avoid potential issues in the future, thereby promoting longevity and reliability in vehicle operation. Please like and subscribe to the channel. See you next time.